In this video, we're going to do some guided exam question practice on the 2004 higher level chemistry question that came up on shapes and bonding. So there was two little bits taken from different questions. In the first one, it says to account for. So there's an action word. It says to account for. This means to give reasons. Give reasons means that's what account for means. Give reasons for the difference in shape of the ammonia molecule, NH3, and the boron trifluoride molecules, BF3. Okay, so the first thing that I want you to do here to tackle this question is I want you to look to the central atom. The central atom of the molecule is the one that there's less of. So in this case, it's nitrogen, and in this case, it's boron. Now we can see that we have a central atom surrounded by three other atoms in both cases. The first thing I want you to do is for each one, nitrogen and boron, look up the group on your periodic table and find out how many valence electrons they have. So pause the video, do that now. Okay, this is really important when we're determining the shapes of molecules, that we know how many valence electrons the central atom has. Well, hopefully you have figured out that nitrogen is in group 5, which means it's got 5 valence electrons. And boron is in group 3, which means it's got 3 valence electrons. So now that we know that, we can go ahead and I want you to go ahead and draw the two shapes. We've got NH3 and BF3. So go ahead and draw them now. Pause the video and do that now. Okay, so what we should have done is we should have put the central atom, as this one as the nitrogen, and hopefully put the central atom, this one as the boron. Next thing we want to do is using dots and crosses to show electrons, draw the valence electrons of the central atom. So in this case, nitrogen has 5 electrons. They arrange themselves like this: 1, 2, 3, that go into bond pairs of electrons with the 3 hydrogens like this. 1, 2, 3. These are the hydrogens. Here are 3 of them. And nitrogen has 5 valence electrons. I've only drawn 3 of them at the minute, the 3 dots. It's also got this other pair that just belong to the nitrogen. And you know here that this here is called the lone pair. So hopefully my students know that this is called a lone pair and that these here are called bond pairs. So ammonia, this NH3, the nitrogen has 1 lone pair and 3 bond pairs. In the boron, it's only got 3 valence electrons. So that means that we just have 3 dots around it. We don't have the other 2. We don't have 5. And those 3 dots make 3 bond pairs with the fluorines like this. So this is F, F, and F. And these are, each of these lines shows a bond pair, and the fluorines have their own electrons, their own other 6 electrons, like this. We know at this stage that all the atoms there are happy. The fluorines have a share of 8 electrons. The boron has a share of 6. It would prefer to have 8, but it's only got 3 valence electrons. It can't make any other pairs. Can't make any other bond pairs. So in this case, this atom just has 3 bond pairs. It doesn't have a lone pair. And this is the key reason for the difference between these two molecules. We say that NH3 has 3 bond pairs, only 1 lone pair. Whereas the boron trifluoride only has 3 bond pairs. And it's this lone pair that changes the angle. Okay, so for your to get the marks in this question, you really needed to give this information here that ammonia had 3 lone pairs and 3 bond pairs and 1 lone pair, whereas this here had only 3 bond pairs. And you could probably get the marks in this question just from 2 good diagrams like this, 2 good labeled diagrams. Let's just check the marking scheme here and see what it said. To get all the marks there, look what you had to have. NH3 has 3 bond pairs and 1 lone pair, and it says either shown or stated. So you could have either written it down like I did afterwards or shown from the diagram. BF3 has 3 bond pairs, and again, shown or stated. So you can get it either way, 3 marks each. Okay. All right. So that's that question. Let's look at the next one. It says show using dot and cross diagrams. So we have to show. So a good thing there is that probably means draw. Show means to draw using dot and cross diagrams the bond formation in a nitrogen molecule. So the first thing I want you to do is write down what is the formula of a nitrogen molecule. So I'm going to go ahead and write it down here. So this is, what is it? It doesn't have a question number, so we'll just call it B1. What is the formula for the nitrogen molecule? So we're going to go ahead, pause the video and write that down. So you shouldn't be playing if you've tried to write the formula for the nitrogen molecule. The nitrogen molecule is a diatom. Di meaning two, atom meaning two atoms. So it's two atoms of nitrogen. It looks like this, N2. That's the first thing you're going to need to know here. Okay. It says show the formation of this. So how does this form N2? So using dots and crosses. Again, think about how many valence electrons are in a nitrogen atom. You already worked this out for the question before. Valence electrons. Nitrogen has 5 valence electrons. So the way nitrogen goes together, it works like this. You've got 2 nitrogen atoms. Each of them have 5 valence electrons. What they will do is they will make 3 bond pairs of electrons like this. 1, 2, 3. And they will share them 3 bond pairs. That gives each nitrogen atom a share of 6 electrons altogether. And notice that we have not drawn all the valence electrons for each nitrogen. For this nitrogen, I've only drawn 3 valence electrons, and we just said they should have 5 because they're in group 5. So that means it's got a lone pair just there, like that. And it's the same for this one. This one also has a lone pair. So if you count up all the electrons each nitrogen atom has, this nitrogen atom has this one, and this one is 2, and then it's got a share of these 6. So there's a share of 8, so it's got a full stable octet. So this here was the answer that we needed for the nitrogen molecule. That's what we had to do. Okay. Next question. Let's go ahead and describe the bonding in the nitrogen molecule in terms of sigma and pi bonding. Okay, so what I want you to do is I want you to label, so for part two, I want you to label out of the 3 bonds here, which ones are sigma and which ones are pi. How many of each should I have? Pause the video, do that now. Okay, so hopefully you have labeled them. And then what you should do is you should just clarify using a sentence down here. Tell me about the bonding. How many of each one are there? So pause the video and do that now. Okay, what you should know is that when atoms are forming bonds, the first bond that's formed is always a sigma bond. But there can only be one sigma. The other ones must be pi. So where we have a double, or in this case, a triple bond, we've got 2 pi bonds. Okay, so just to clarify, nitrogen, triple bond. So the triple bond here in nitrogen contains 1 sigma and 2 pi bonds. Now you might have just said 1 sigma and 2 pi bonds, and that will probably get you the marks just fine. Okay, all right. Next question. What type of intermolecular forces would you expect to find in nitrogen gas, and explain? So don't forget to explain. So in this molecule here, if we have a molecule of nitrogen like that, there's a nitrogen triple bond, and we bring another one close by, how will these attract each other? What type of intermolecular forces will there be? So it asks you to give a type and explain your answer. So I'm going to call this part 3. I'm going to say intermolecular. So you're just going to name a type of intermolecular force that you expect to form here, intermolecular, and then it says to give a reason. So pause the video, write down what type of intermolecular force do you think is between nitrogen molecules, and give a reason for your answer. Pause the video and do that now. Okay, so the type of intermolecular forces I would expect to find here are van der Waals forces. How do I know that? How do I know it's van der Waals? What's the reason? The reason why I know it's van der Waals is because I know these molecules are going to be non-polar. I could do a calculation and confirm that, but I know just a shortcut in my head here. I've got 2 atoms of the same type. They're going to share the electrons exactly in the middle, and there's going to be no dipoles. So no dipoles whatsoever. So the electronegativity difference between the 2 nitrogens is 0, which means we've got the electrons shared exactly in the middle. No dipoles, no positive and negative areas in the molecule, so therefore it cannot be polar. So if we've got a non-polar molecule, non-polar molecules are always van der Waals forces between them. So reason why, molecules are non-polar. That's a reason why. Okay. All right. So what I'm going to do is I'm going to put up the marking scheme now, just so you can see and check over your answers and confirm them. Okay. So here you see the first part, your diagram for your dot and cross diagram of nitrogen. Yeah, that's fine. Dot and cross diagram of the nitrogen molecule. Describe, we've got 1 sigma and 2 pi. So that was the triple bond. What type of forces? Van der Waals forces. And why, explain why molecule is non-polar. Or you could have said pure covalent. But yeah, non-polar is the reason why. Okay, guys, so that is another question covered on bonding, in particular shapes of molecules. It comes up very common question. So that's it, guys. We'll see you in the next one.